to Assembly Audible, the podcast dedicated to exploring all aspects of product assembly. I'm your host, multimedia editor Jennifer Pierce, and we're so happy you're listening in today. We're recording from the Assembly Show in Rosemont, Illinois, and I am joined by Ben Brakenwagen, account executive with Dirac. He's joining us today to talk about how critical automated work instructions are, and even more specifically, Dirac's platform called BuildOS. Welcome to the podcast.
Thank you, Jennifer. It's great to be here.
Absolutely. So what is model-based manufacturing, and how are companies or customers leveraging it to improve their manufacturing processes and enable their digital transformation? Quite a bit in that question.
Yeah, that's a thick one. Model-based manufacturing is essentially using the 3D model as your single source of truth throughout your manufacturing process. So we've seen pretty good adoption of model-based design, and we've kind of trying to cross the bridge over into the manufacturing lens. So what that really means is pointing all your data throughout the manufacturing process all back to this 3D model, which is now your single source of truth. So you're making assembly instructions point to the model, you're making your QC point back to the model, your documentation, MRO, all these things pointing back to the model, and you're creating this digital thread of information throughout the process.
All right. So tell us about a moment when a team went from 3 days of documentation to a few hours. What changed and what stayed stubbornly human? And that would be, of course, utilizing your platform, right? BuildOS.
Yep.
Is that the framework of this question?
So we've actually seen this a lot. People come in, they have 3 to 4 days spent to make one work instruction, and then they use BuildOS and it takes 2 hours, 3 hours. So it's a step change, but I can walk you through.
Yeah, please tell us what it does.
Yeah, absolutely. So BuildOS essentially automates that work instruction platform. It is a tool dedicated to manufacturing engineers to be able to manipulate the model, resequence things, and make these instructions in an intuitive manner. One of our earlier customers, Anchor Aircraft, they were the first example of that 4-day to 2-hour transition. They brought us in. They're industry-leading aircraft cargo loading system supplier.
I saw this on your website.
Yeah,
it was really interesting. So I want to know more. I thought it was really fascinating.
Yeah, they make some cool stuff too. They brought us in for the MPI of this new contract that they got, just to see how it would work and try to get this product out the door faster. And within 6 weeks, they decided to put BuildOS to the entire organization. They were spending significantly less time making work instructions. They were spending less time on scrap, and operator ramp-up time was reduced. And they now had a revision control of their work instructions, which they didn't have previously. So they put it to the entire organization. I think the metrics that we have on them was 95% reduction of time spent on work instructions. So pretty substantial. And as they needed more revisions, they could do them quicker. So things just were a lot more seamless with that.
Yeah. So what exactly was the problem? Was it because the work instructions weren't digitized? Is that why?
No, they were using digital instructions. They just didn't have a tool that really empowered them to make them. So it was just incredibly manual screenshots of a CAD model, screenshots of post-produced products and to drive how it was supposed to look, or text driving how they're supposed to assemble it, and operators are supposed to know how to put together a machine based on text. It's you're a lot of inferencing going on for an operator, especially if they're new. That leads to a lot of issues. But so the problem is that they didn't really have a tool that empowered them to make the instructions.
I see.
Yeah.
Okay, so where exactly does the CAD to workstation translation typically fail, and why hasn't traditional software closed that gap? This is a good question. I love this question.
Yeah, that is a good one. So there's a multifaceted answer to that. I would say, so I'll break it down into 3 different buckets. There's the simple adoption from CAD to workstation. Then there's the feedback loop of workstation to CAD. And then there's also the information transfer from design to manufacturing. So the simple adoption, some people use CAD on the line, but there's no real good way to consume it in an intuitive assembly manner. So that's kind of where that one struggles. Then you have to be so intentional about getting feedback back to the designers from the line. So that'll require either the operators redlining the assembly instructions, bringing them to the engineers, or the engineers going out of their way, going to the line and seeing how the operators are actually doing it and trying to work it that way. But what we see a lot is that operators just start iterating their process and it doesn't actually get implemented. So now the process that's happening on the line doesn't actually reflect what the instructions show, and that obviously leads to issues down the line, especially if that person leaves, new person comes in, blah, blah, blah. And then the third thing is the information transfer throughout design and manufacturing. Right now, work instructions are this like rogue path off the normal data line, and it's just like this random point where the work instructions live. With BuildOS, work instructions are a stepping stone right between your design and your manufacturing. So if you have data in your PLM and you need to then translate it into the ERP, BuildOS actually is that process. So as opposed to making work instructions this, random effort because you need it, it's actually linear with the rest of the process.
It's integrated into the process. That makes a lot of sense.
So that way, sometimes, especially if it's, high mix, low volume situation, sometimes it doesn't even make sense from an investment of time standpoint to make work instructions.
Interesting point.
But if you are translating your data from design to manufacturing at the same time, then it's a lot more justifiable. And then there's obviously a lot of benefits to having work instructions versus not having work instructions.
Yeah, absolutely. That makes a lot of sense. So what makes a work instruction truly repeatable across shifts, products, and plants? And not dependent, I guess, on the person doing it, right?
Yeah, I mean, that's a good question. I would say highly educational and rigid are the two things that make an instruction actually scalable. Like I was saying earlier, operators will start having their own kind of flair to it as they start building, from what we've seen. So that first X amount of builds is so critical to getting them into a process flow that works. Because once you do it 10 times, you may still be flipping through the instructions, but you're not really thinking about the instructions.
Right, absolutely.
You know what you're doing. So making sure that those first ones are actually educational and clear cut, that they learn a way that's effective, is incredibly important. And then rigidity is important because that way you don't have quality issues. It's actually rigid for the operator to be able to funnel towards a product that is successful. On the flip side, I think rigidity is important for the instructions, but I think adaptability is very important for the process of making the work instructions, because products change, new SKUs come out. You need to be ready to move, and the only way to do that is having a infrastructure in place that can adapt quickly. So although the instructions are rigid, the way that you make them kind of needs to be flexible.
Interesting. Okay, so when people say reindustrialization, they jump to capital investment and supply chains. Because again, the title of our podcast today is From CAD to Clarity, Why Automated Work Instructions Are the Critical Step in Reindustrializing the West. So, why do you argue the humble work instruction is the linchpin? And what breaks first when instructions are unclear? Quality, throughput, or safety? That last part's pretty good. That's a tough one.
Yeah, this is good.
There's a lot packed in right there.
Yeah, okay, so I'll go for the first part of the question. Reindustrialization is a quite complex concept. There's a lot going on in there. I mean, jumping to capital investments and supply chain, those are very important factors, but reindustrialization as a whole is it's a mouthful.
Yeah.
It's really hardening the entire industrial base. So you kind of need to rethink and reform pretty much all aspects of it. And so, although capital investment is a big part of that, and consolidating and rethinking about supply chains is very important, we are focusing on the work instruction, the humble work instruction, because it's the blueprint of the modern day. And blueprints are what drive design, they design manufacturing, and it allows for agility throughout the industrial base as a whole. So if you have really, really good work instructions, you can plop that work instruction into a new facility quite easily, where if you have very poor documentation, it's almost impossible to just do an agile flip, open a new facility, spin that up quickly. Like, the work instruction is the backbone of agility throughout the industrial base as a whole. So that's why we focus on it. But yeah, reindustrialization is, it takes effort from everyone. I think, everyone here and everyone throughout the country is kind of working on it in their own way, and it's all important.
Yeah. Some of those philosophies were outlined on your website. I thought it was interesting. So if our listeners want to check out, I can't remember the URL right now. Is it just Dirac.com?
Dirac Inc.
Okay, Dirac.
DIRACINC.
Okay. Awesome. Yep. And then the second part of the question, I guess, would be, what breaks first when instructions are unclear?
Yeah, this is a good one. It totally depends on the facility from what we've seen. Some facilities focus a lot more on quality or safety. Some focus a lot more on speed. And it's usually whatever you're not focusing on breaks first. But once something breaks, everything starts breaking. So if the work instruction isn't good, and a couple of weeks in, you have a quality issue pop up, I'll put a huge bet down that in the short term, there's going to be issues in safety and there's going to be issues in speed. Just because quality came first doesn't mean that it's just going to be a quality issue. It always starts trickling down. So until you fix that core issue of the work instruction, things are just going to deteriorate.
That's interesting.
Not to be pessimistic.
No, but yeah, but it's a really interesting angle. So how can our listeners learn more about your automated work instruction creation platform, BuildOS?
Yeah, absolutely. I mean, check out our website. Like I said, it's diracinc.com. You can message me. My email is ben@diracinc.com. You can give us a call.
We also have a 1-800 number. I'm just
No,
kidding.
we do not. But maybe that's coming soon.
Yeah, you never know. All right, well, thank you so much for your time. Is there anything you'd like to close with before we finish the podcast today?
No, I mean, give us a look online. If you want to see what your work instructions look like in our platform, we're happy to run you through one of your assemblies. It's incredibly cool. If you like 3D tools like I do, it's worth just checking out just to, stimulate the mind. But yeah, I appreciate you having me on today.
Absolutely. Thank you so much, Ben.
Of course.
Thank you for tuning in to this episode of Assembly Audible. We invite you to check out all of our content, webinars, and events on assemblymag.com. Also, please follow us on social media. Until next time, I'm Jennifer Pierce, signing off from The Assembly Show. Thanks for listening.